Hey everyone. So this is our last video together. And for some of you, it's going to be the easiest. For some of you, it's going to be the hardest. It's game theory. Now, with game theory, it's hard to teach you what to do with game theory. I'm going to give you some pointers and we're going to go through some games together that you can try. But there's no set do it this way and it will always work sort of a thing, because on your diploma, you're going to have a game that's not the same as the games I'm about to give you. The whole purpose is to introduce a new logical game to you and ask you to try and deal with it. Okay, but we'll go through some together and just see how you're feeling. Okay. There will usually be about 3 games on your diploma, and they often start your diploma with the games. Now, that could be a good thing if you know what you're doing right away. Like if you can see a game and you're like, oh, that's totally easy, I totally get this, then go ahead and do it right away. But if you look at a game at the very beginning of your diploma and you're like, I don't know what the heck that's talking about, move on, okay? Don't sit there and try it right then. Do the stuff you know how to do first. You don't have to complete the exam in a particular order. So do all the stuff you know how to do first, and then go back and start playing around with the ones you weren't quite sure with. Okay, so the purpose is to test your logical reasoning. We will go through some today, but chances are it'll be a different setup on your diploma. Our purpose is just for you to get the feel of thinking through them. Okay, and I just said that, don't spend too much time on them, okay? All right, so the word spot compares to stop, as the number 5381 compares to the number what? So all you got to do here is write the word spot, S-P-O-T, and spot is 5381. Now I'm going to move that to stop. Well, if I do that, S is still 5, T is 1, O is 8, and P is 3. So it'd be 5183. Okay, so I'd have D there. Okay, to complete the 3x3 puzzle shown below, the digits 1 through 9 must be used so that each row, column, and diagonal adds up to 15. A partially completed puzzle is shown below. The letters for A, B, C, and D represent unknown numbers. To correctly complete the puzzle, what does A, B, C, and D have to be? Well, everything has to add up to 15. So I can't really start with A and B together in this row because that's 2 unknowns, but I could start maybe here and say, okay, well, 5 and 7 is 12. So to get to 15, A has to be 3. Okay, then I could go to here and say, okay, that's 11. So B is going to have to be 4. Then I've got 4 and 2. So that's 6. To get to 15, B would have to be 9. And then for this guy here, I've got 9. And really, take a look, you know you're doing it right, because if I look at this row, I have 9. If I look at this column, I have 9. And if I look at this diagonal here, I have 9. So everything is pointing to the right direction. What do I need to go with the 9 to get 15? D has to be 6. Okay. So 3, 4, 9, 6 would be the answer to that. All right. Sasha has 6 white socks, 4 black socks, and 10 brown socks in the clothes dryer. Without looking, because this is a game everybody plays in the morning, I guess, I don't know. Without looking, he randomly selects 1 sock at a time until he gets 2 socks that are the same. The number of socks that Sasha must randomly select from the clothes dryer to guarantee that he gets 2 socks that are the same color but not white is what? Now, kids have a hard time with this one because of the thought process behind it. He could, in theory, pull 2 socks out and get 2 black socks right on his very first pull and be done, right? That could happen. Logically, it could happen. But that's not what they're asking. They're saying he is not looking, he's closing his eyes, and he wants to guarantee that the amount of socks he pulls out will give him a matching set that's not white. So we have to look at the absolute worst case scenario, okay? The absolute worst case scenario, first of all, would be that I draw all 6 white socks because I don't want any of those. So there's my 6 white socks. So it has to be more than 6 at the moment, okay? Okay, now think about that 7th draw for a second, as all the white socks are gone. So the 7th draw, I'm either going to pull out a black sock or a brown sock. The 8th draw, do I now guarantee a pair? Well, no, because I could have pulled out the other dude, right? I could have on the 7th draw drawn a black and on the 8th draw drawn a brown, and I still don't have a pair. But the 9th draw, I am now guaranteed I'm either going to have a pair of black or a pair of brown socks. Okay, so it would take 9 pulls of socks to guarantee that I've got a pair that's not white. Okay, a pattern is shown in the shapes above. If the pattern continues, which of the following shapes is next? Now you have that in your book, but I will just take my video off for a sec so that you can see it and that I'm not in the way. There's a lot of different ways you can do this because there's a lot of different patterns going on here. I might look at this first of all and say, okay, black on top, then gray, then white, then black. So I'm going to need gray on top. So that would rule out A and B to me. Okay, then I might look at gray on the bottom, white, then black, then gray. I need white. Well, that doesn't help. It's still C or D. I could go little triangle to big triangle to little triangle to big triangle. I'd have to go little triangle next, which would tell me the answer would be C. Okay. All right, good. Having fun with games yet? Okay, Ken. This 4x4 Ken game must be solved using only the numbers 1 to 4. Do not repeat a number in any row or column. The darkly outlined sets of squares are called cages, and the numbers in each cage must combine in any order to produce the target number using the operation shown below. So essentially, I have to put 2 numbers here that my 2 numbers will add together to give me 3. I'm only allowed to use the numbers 1, 2, 3, and 4. Okay. And the question is, what number goes in the shaded box? Okay. So there's a bunch of different places we could start. I'm going to start right here with that 8. Now, these 3 numbers have to add up to 8. Okay. I'm only allowed to use the numbers 1, 2, 3, and 4. I'm never allowed to repeat numbers in a row. So the only way to do that is those 3 numbers are going to have to be a 4, a 1, and a 3. 4 plus 1 plus 3 would give me 8. There's no other way to do that with 3 numbers. Okay. Okay. Then take a look at this 6. I have to multiply 3 numbers to get 6. The only way to do that is to have that be 1, 2, and 3. 1 times 2 times 3 is 6. That tells me if my 1, 2, 3 have to go here, the 4 has to go here. So I know for sure that that guy's going to be a 4. Okay. All right. Now, I know that I need a 1, 3 here somehow. Sorry, a 1, 2 here. And I know I need a 1, 3 here. So then I could look at this guy and say, okay, 2 numbers that subtract to give me 2. Well, that could be 3 and 1, or it could be 4 and 2, right? I need the 1 up here somewhere, and I need the 1 up here somewhere. So chances are it's not going to be 3 and 1 here. Chances are it's going to be 4 and 2. Do you know what I mean? But now you're going to kind of start penciling things in. I'm going to go over to here next. Okay. And I'm going to say, hey, 4 Well, I can't do 2 and 2, so it has to be 1 and 3. Okay, has to be 1 and 3. Well, you could just start putting something there and seeing if it works. So let's say I say this is 1 and this is 3. Okay, if I did that, up here, I would need the 2. And, oh, sorry, no, I would need the 3. I'm just going to put my ink back on, sorry. This up here would need 1 and 3, right? So this would have to be 3 and 1. Okay, I'm not saying this works. I'm saying we're just trying something to see. Now, I need you to understand why I had to put the 3 there. In this column, I can't have repeating letters. So if I've stuck a 1 there, I'd need a 3 there. Okay. The only way to get 7 is with 3 and 4. Well, look at this now. I have nowhere to put the 3. I can't put the 3 here, and I can't put the 3 here. Okay, so that tells me the scenario I've started with doesn't work. So let's try the other guy. Let's try going 3, 1 instead. If I do 3, 1, up here, I've got 3 and 1. Okay, then my 7 could be 4 and 3. Then this would have to be a 2 now because I have 1, 2, 3, 4 represented here. Okay, which means my 1 goes here. You follow what I'm doing? This we said was 1, 2, 3. Well, I can't put the 1 here and I can't put the 2 here, so the 3 is going to have to go here. I can't put the 1 here because of this row here, so the 1 would have to go here, and the 2 would have to go here, which means the 4 would have to go here, and the 2 would have to go here, so that works out there, and then the 4 would have to go here, 3, 1, 2, 4 that way, and the 2 would have to go here, and that cage works out as well because 4 divided by 2 is 2. Okay, so I got excited and got ahead of myself. In a minute, I was going to ask you to finish the Ken puzzle, but I just did. Hopefully that makes sense as I did it with you. But to first answer this question, it's that the number that goes in the shaded circle, well, or sorry, the shaded square, that would be 3. Okay, so I'll clear my drawings and we'll just build that through again. Okay. You can see that I did it with a slightly different logic to get to 3 up there. There's lots of different ways to do these puzzles. Okay, then we said, can we finish it for fun? And yes, we can. And there it is. Okay. Okay. This is another type of logic puzzle. For the following puzzles, each consists of a blank grid with some clues. So some means addition. The object is to fill all the empty squares using the numbers 1 to 9 so that the sum of the horizontal block equals the clue on its left and the sum of each vertical block equals the clue on the top. So for instance, these 2 numbers here have to add up to give me 4. These 3 numbers here have to add up to give me 19. That's what they're saying there. Okay. In addition, no number may be used more than once in the same block. Okay, so there's a few different places you could start playing around with. I'm going to start here with 6. 3 numbers that add up to give me 6 are going to have to be 1, 2, and 3. Okay, so either this guy here is a 1, or it's a 2, or it's a 3. So I could just start playing with it and seeing what happens. Let's say I chose 1, 2, 3. I can see right away that that doesn't work. Okay, and the reason it doesn't work is because to get 6, I'd have to have 3 and 3 here, and I'm not allowed to do that. Okay, so I know, then I also know that okay, let me just walk you through that. Okay, so 1, 2, 3 doesn't work. Maybe 1, 3, 2 works. Let's try that. 1, 3, 2. Well, no, right away it doesn't work because I don't have anything to add here to get to 3, right? This would essentially have to be a 0. 0 is not an option. So I know for sure the 1 does not fit in that section. Okay, so let's try 2. So with 2, I know I can't have 3 here for that same reason I just had. So it would only be 1, 2, 1, 3. And again, that doesn't work because of the 6. That would be 3 and 3. So that tells me this has to be a 3. Okay. Now, my options are going to be 1, 2, or 2, 1. Okay. If I did 1, 2, this would become 4. This would become 3. No, sorry, this would become 2, and this would become 1, which seems to work. Let's just see if the other guy works as well, because if the other guy doesn't work, then we know for sure that that's true. Okay. So if I went 3, 2, 1, this would become 5. This would become 1. And this would become 1. And I can't have that, right? Because I can't have 2 of the same numbers in the same block. So I'm very, very confident now to say it has to be 3, 1, 2. Okay, and so now I know for sure that this would be my 4, my 2, and my 1. Okay, now I'm going to head over here. I see this 4, and I'm going to go, okay, let's go 1 and 3. Could also be 3 and 1. I'm just going to check them. Okay. So if I was to go 1 and 3, with the 19, I'm left with 18. Right? Like these two numbers would have to add up to 18. Well, how do I add up to 18? I could go 9 and 9. And that's it, right? I'd have to use a number higher than 10 to get up to 19. Unless I use 9 and 9, and I can't use 9 and 9. So that tells me the 1 and 3 doesn't work. It's going to have to be the other way. It's going to have to be the 3 and 1. Okay, so I'm just going to erase that, and we're going to go with the 3 and 1. Okay, so now, what do I have left here? Well, I've got 16 this way. I've got 16 this way. I've got 17 this way. And now take a look at this guy for a sec. 21, I've got 17 this way, right? Because 21 minus 1 is 20, minus 3 is 17. So 17 is still a fairly high number. 9 and 8 is the only way I can make 17, right? Unless I use a number higher than 10, and I'm not allowed to do that. So again, I'm going to play with this and say, okay, this is either 9 and 8, or this is 8 and 9, and one of them is just not going to work. Okay, so let's play with 9 and 8 for a sec. This would give me 1 plus 8 is 9, and then I would need a 9 here, right? And then for 16, I would need a 7, and that actually does work, right? 3, 7, and 9 is 19. 1, 9, and 8 is 18, and 17, 20, 21. So that scenario works. Okay, so this would be my answer. Okay. Okay, a little logical puzzle here. The 3 little pigs built 3 houses, one of straw, one of sticks, and one of bricks. By reading the 6 clues, deduce which pig built each house, the size of each house, and the town in which each house was located. What you need to understand with logic puzzles is what you don't know. Sorry, I said that backwards. What you know is not true is just as important as what is true, okay? So I have a little table down here that I'm going to work with to start filling in things I know. Penny did not build a brick house. So Penny's house was not brick. That's going to be very helpful. The straw house was not medium. That'll also be very helpful. Peter Pig's house was made of sticks. Okay, that's something I can put right away. If Peter's house was made of sticks, then I actually know Penny's house as well, because I know Penny wasn't brick. So Penny can't be sticks either, which means I know Penny was, what was my other sticks? No, sorry, straw, stick, and bricks. Why sticks and bricks have to rhyme with each other, you know? Okay, so I know Penny was no brick. I know Peter was sticks. So as soon as I know Peter was sticks, I also know Peter was large because he was neither medium nor small. Well, the only option there is large, okay? Patricia built her house in Pleasantville, so I know where Patricia built. I want to make sure you understand how I just did that. I'm going to go back one more time. Because Penny is no brick and no sticks, I know for sure that Penny has to be the straw, which means that leaves Patricia with the brick, okay? Then I know that the straw house was not medium. So now that I know Patricia has the straw house, sorry, Penny has the straw house, I know that the straw is not medium, but it's also not large, okay? So that's how I filled in all of these things. The straw had to be the small house, and that left, we knew Patricia had the brick, but that left it being the medium, okay? Now, Patricia Pig built her house in Pleasantville, so I know Patricia's Pleasantville. I know the large house was Hillsdale, so that's going to be Peter, and then the other town is Riverview. Okay, and then we filled in everything. So we know Penny built a straw house, which was small and in Riverview. Peter built the stick house, which was large and in Hillsdale. And Patricia built the brick house, which was medium and in Pleasantville. Okay. All right. The goal of this puzzle is to fill the circles in a grid with numbers 1, 2, 3, and 4, so that no numbers are repeated in any row, column, or set of connected circles. So it's kind of like a can-can, but the difference is now you're looking for these set of connected circles, and I have to have 1, 2, 3, 4 in that set, okay? 3 entries in the gray circles were given to start the puzzle. Jerome has already completed another 3 entries, which are in the white circles, but he screwed up. Correct the error that Jerome made and complete the puzzle. So Jerome said, hey, I need a 3 here, a 2 here, and a 3 here. Well, if we follow Jerome's logic, I'd have to have a 4 here because I need 1, 2, 3, 4 in every row, column, and set of connected circles. Okay, and then I'd also need a 1 here. Now that looks good. 1, 2, 3, 4 is in that cage, right? 1, 2, 4, this would have to be a 3, and that doesn't work because I have 2 3s in the same row. Okay, so Jerome messed up. So the first thing we're going to do is talk about how Jerome messed up. So I said the 3 doesn't work. To the left of the 4, you would need a 1, which leaves a 2 to the right of 3, but there's already a 2 in that group of circles, okay? So now I actually gave it another reason on my PowerPoint why it didn't work than what I just said to you. This is the nice thing and sometimes frustrating thing about logic is there's many avenues to get to what you're trying to say. Okay, so let's see if we can figure it out the correct way. Okay, and for the correct way, I'm actually going to start here. I know that in this cage, I still need a 1 and I need a 3. Well, I can't put the 1 here because that would have a double 1 in that row. So I have to put the 1 there. I know for sure that that's going to be 1. Now that I know for sure that's going to be 1, I can say, hey, this guy has to be 3. Okay. Then I'm just going to put my ink on and do this with you for a second. I know this guy has to be 3. Over here, I need a 2 and a 4, but I can't put the 4 here because that would double 4 in this column. So this is going to have to be my 2 and my 4. 1, 2, I'm missing a 3 in that cage. So then this would have to be a 2. Okay, and then I just keep going. I'm going to let you fill it in before I show you my answer. So pause me. and here's the final product. Okay, see how you did. Okay, the goal of a particular two-player game is to be the first player to create a line of 4 adjacent rectangles containing the same letter. To play, each player takes turns placing their first initials somewhere on the 6x6 grid. Margaret and Gerda have started playing this game as shown in the grid below. It's Margaret's turn, so we're going to place an M. And she determines that she can guarantee a win by placing the letter M in what row and what column. So take a look at this, take a look at the board. You have it in your book, but I'll turn myself off for a second just so that you can see the board. And what I would want you to see is we'd be looking at right here. If I placed an M here next, no matter what Gerda does, she can block me here, and then I could win this way, or she could block me here and I can win this way. But by placing an M right there, I've actually guaranteed my win. Okay, so that would be row 4 and column 2. So my answer would be 4, 2. Okay. Okay. This is a heavy duty logic one. I'm going to get you started on this, and then you're going to pause me and finish it yourself, and then you can check your answers, okay? 4 girls, Alice, Brenda, Kathy, and Diana, go to a recreation center in a large city. Each girl participated in a different activity. So we've got weight training, skating, jogging, and swimming. And each girl owns a backpack of a different color, blue, pink, green, and red. The 4 clues below provide information about the activity in which each girl participated and the color of each girl's backpack. Determine the activity in the backpack of each girl. The trick to these guys is, as soon as you know something, like say, you know, Kathy is a red backpack. Nobody else is a red backpack if Kathy was. So as soon as you know that one thing, make sure you exit all the things that are now not possible because of the one thing you know. Okay. Okay, so Kathy does not have a red backpack. So I will go to Kathy and I will scratch out red. Okay. And she needs to dress warmly for her activity. Well, she doesn't need to dress warmly for swimming, and she doesn't need to dress warmly for weight training or jogging. So we're going to say, yep, Kathy is skating. As soon as I say that, yep, Kathy is skating, watch what happens. That means nobody else is skating, and Kathy is nobody else. So I can exit all of those guys. Okay. The swimmer who owned the red backpack was not Brenda. Well, what do we know from that? We know that the swimmer owns the red backpack. So swimming is red. So I can put a yup on that guy. Okay. Notice that I also took out Brenda can't swim, or she's not, that's kind of an assumption of mine. I'm saying she's not the swimmer. I don't know that she can't swim, but she's not the swimmer. So I exited that guy out. Okay. And that tells me that Brenda's not red too, because it's the swimmer who's red. So that's all the information that I know just from that one line. Okay. The girl who carried the green backpack was jogging. So the jogging is green. Okay. And again, that means I can exit out everything else. Okay. All right, and then while preparing for her jog, Diana, okay, so right away we know Diana is the jogger, so we're gonna say, yep, for Diana being, I exited out the green for Kathy as well. Because I know Kathy wasn't jogging, so Kathy can't be green, okay? So now Diana is jogging, so then I can exit out all of that guy. And she watched her friends take her skates out of her blue backpack. So we know Kathy was skating, so we now know Kathy was blue. Okay, and we're using process of elimination here. to figure out all the other guys. So where I'm putting all these yups is because I can't have 4 nopes. So suddenly, once I've got all my X's in place, it just goes bing, 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 because there's only one option left. Okay, so Alice was swimming with a red backpack. Brenda was weights with a pink backpack. Kathy was skating with a blue backpack, and Diana was jogging with a green backpack. Now, the magic of doing this in video, it wouldn't hurt to go back and just watch that process once or twice more, okay? It's not that you're gonna have one of these puzzles on, but it's just, it helps in your thinking, okay? It's all about what do I know for sure and what do I know isn't true for sure. Both of those are equally important in these types of things, okay? All right, last question. 6 marbles are identical in size, shape, and color, but one of them's heavier. If you were to use a balance scale shown above only 2 times, how could you determine which marble is heavier than the others? Okay. Pause me and write something down yourself, and then I'll show you my explanation. Okay, so here's my thought. I have 6 marbles. I could go in 2 groups of 3 and place them on the scale. The heavier marble in that group is going to cause that scale to tip. So I know right away which of those 3 is going to have the heavier marbles. Okay. Then of that group with the heavier marbles, I can put 2 on this. I can put 2 on each side of the scale. Either they're going to be equal, which means the one I didn't use is the heavier one, or the heavier one's going to cause it to drop. Okay, so place 3 marbles on each side of the scale to determine which set of marbles is heavier. Discard the lighter set. From the 3 marbles left, place 1 on each side of the scale and set the last marble aside. If the scale's unbalanced, you know which marble's heavier. If the scale is balanced, the marble you set aside is the heavier one. Okay. All right, that's it. That concludes our game theory, and that concludes our whole video time together. I really, really hope this has been helpful. I really hope you're feeling better about some of these concepts than when you started with me. Good luck. Make sure you watch all these videos a few times and let it get into your head, okay? Get a good night's sleep the night before your diploma. Have a healthy breakfast that day. You got this, okay? It's gonna go awesome, okay? And let me know how it goes, okay? Good luck, guys. Take care.